Okay, our second lesson for week 10 is steps, we're doing dividing rationals. And dividing rationals literally is very, very, very close to multiplying. So you invert and multiply what you're dividing by, or you flip and kiss, as some of your teachers have said. You factor the numerators and denominators just like we would have for multiplication. The only catch is that you're going to flip the right-hand side of the fraction and turn it into multiplication. So there's a catch with non-permissible values. So you have AB, let's pretend, divided by CD. Well, you would normally state non-permissible values for both these denominators. That's what we did for multiplication, right? But your next step after you do GCFs and difference of squares is to multiply and flip the next expression, right? So previous to flipping it, you stated NPVs for B and D, but now after flipping it, you're going to state NPVs for B and C. So the catch with dividing is you do the exact same steps as multiplication, except you have to flip to multiply, and you have to state non-permissible values of both the denominators and the right-hand numerator. Not the left hand, just the right hand. So this is only for division. Do you actually have to state non-permissible values of a numerator of the top, and it's only of the right-hand top. But then you follow all the same steps as multiplication. And they're listed for you here if you need to go back and look at them. So we're going to go to the next page. So, simplify each rational expression and state non-permissible values. So this time it's division. So we're going to do the same steps as multiplication. The very first step is GCF and difference of squares, all the tops and the bottoms. So I look at the top left, it's x minus 3. Well, I can't do anything to that, so it's just going to stay x minus 3 in brackets. Then the bottom left denominator, 2x minus 5. Can't do anything to that, so it's going to say 2x minus 5. Divided by top right-hand numerator, x plus 1. Can't do anything to that, so it stays x plus 1. And then the bottom is just x, so it stays just x. So our next step is to flip the right-hand side, and it turns to a multiplication. This is the extra step for division. So I get x minus 3, 2x minus 5, so stay the same. Then I get a multiplication symbol instead, and these change. So I'm going to get x over x plus 1. And now I have to state NPVs for this and this, but also this, because it used to be in the denominator. So there's just that extra NPV in division. So I'm going to go over here and I'm going to state my NPVs. So I have 2x minus 5 cannot equal 0. I have x plus 1 cannot equal 0. And I have x cannot equal 0 because it used to be in the denominator. And the x cannot equal 0 is done. I have to solve the other one. So I'm going to 2x plus minus 5, I'm going to have to add 5 first. Then I have 2x cannot equal 5. And then I have to divide by 2 to get x by itself, to get rid of that multiplication. So I get x cannot equal 5 halves. And then here I have x plus 1. I'm going to subtract 1 from both sides. I'm going to get x cannot equal negative 1. Now I have multiplication just like I had before. So what can I do? Combine the numerators and the denominators and cancel off anything that's the same. So I have an x minus 3 in the top. I don't have an x minus 3 in the bottom, so it's staying. I have a 2x minus 5 in the bottom. No 2x plus minus 5 in the top, so it's staying. I have an x plus 1 in the bottom. No x plus 1 in the top, so it's staying. And I have a single x and no x squared, x cubed, or anything by itself in brackets. So it can't actually reduce any further. So I actually have x minus 3, or x minus 3 times x. Doesn't matter if you order them differently. And then 2x minus 5, x plus 1. And x cannot equal 0, negative 1, 5 over 2. All right. Then let's look at B. So the first step we do, once again, is just like we did for multiplication. we're going to go to each numerator and denominator and see if we can GCF or difference of squares them. So I have x minus 5, can't do anything to that. So I'm going to still have an x minus 5 in the numerator on the left. The denominator on the left, I can take a 3x out. And then I'm left with x minus 3. 3 in brackets, x in brackets. Divided by negative 5 in the numerator is going to stay a negative 5 because I can't do anything to that. And the right denominator, I can take out a 6. And I'm left with x minus 3. So when I divide 6x by 6, I get x. And negative 18 by 6, I get negative 3. So my next step is to flip and multiply, but only the right-hand side. So I'm going to get x minus 5, and then on the bottom, I have 3, I have x minus 3, multiplication symbol, and they're going to flip. So I'm going to get a 6 and an x minus 3 now on the top, and a negative 5 now on the bottom. And remember, with division, I state NPVs for all the denominators and the right-hand numerator. So I'm going to do my NPVs. So I have 3 cannot equal 0, which isn't an NPV. I have x cannot equal 0, done. I have x minus 3 cannot equal 0. I have negative 5 cannot equal 0, not possible. I have 6 cannot equal 0, also not an NPV. And I have x minus 3 again, cannot equal 0. If I've already have it once, I don't have to state it again. So I'm going to only do the top one up here. So I'm going to add 3 to both sides. So you don't have to state an NPV twice if it appears, if it's the same one. And x cannot equal 3. So I have 2 non-permissible values, or restrictions, 0 and 3. Okay. So x minus 3 and x minus 3 cancel. Some people try and cancel this negative 5 off with the x minus 5, but you can't, because the x minus 5 is attached, so it's only going away if there's an x minus 5 in the bottom, which there isn't. So I think I'm done. So I have 6, x minus 5 in the numerator, over 3 times negative 5, so negative 15, because you multiply those numbers that are by themselves together if there's 2 of them without variables, and an x. And then I say, wait a second, 6 and negative 15, I can take a 3 out. If I take a 3 out of 6, 6 divided by 3 is 2. If I take a 3 out of negative 15 divided by 3 is negative 5. And we're left with 2 x minus 5 all over negative 5x. And it can be in its own brackets if it wants. And I'm going to get x cannot equal 0 or 3. Then we're going to go to C. So once again, I'm going to GCF and difference squares my numerators and denominators. My left-hand side, 2w, is just going to be 2 and a w in brackets separately because they're multiplied. 24w plus 4w squared. I can take a 4w out. 24w divided by 4w is 6. 4w squared divided by 4w is w. And then the 4 and the w are in their own brackets because they're multiplied. Divided by 6w squared minus 6w, I can take a 6w out. When I take a 6w out of 6w squared, I get w. And then minus 6w divided by 6w is minus 1. And then the 6 and the w are in their own brackets. The denominator, I have 9w cubed plus 54w squared. I can take a 9w squared out. I take 9w squared out of 9w cubed, I'm left with w. 54 divided by 9 is 6, and then w squared, gone. And then the 9 and the w squared are in their own brackets. Then I have to do NPVs. Okay, so I'm going to do it for 4. w, 6 plus w, 9, w squared, w plus 6, 6w and w minus 1, because I have to do it for all of them except for the top left, so it's lots. So 4 cannot equal 0, doesn't get me an NPV. W cannot equal 0, perfect. 6 plus w cannot equal 0. I'm going to subtract the 6 over. W cannot equal negative 6. Good. Then I have 9 cannot equal 0. True, but not an NPV. W squared cannot equal 0. Square root w. You get w cannot equal 0. Plus or minus sign. So there. Oh wait, it's the same as the other one. Then I have w plus 6. I've already done that. And I have 6 cannot equal 0. Not an NPV. I have w cannot equal 0. I've already done that one up here. And then I have w minus 1 cannot equal 0. Add the 1. W cannot equal 1. So actually I have 4 NPVs. 0, negative 6, 0. Oh, that's already stated. So actually 3. 0, negative 6, and 1. Now I can flip and multiply. So I have 2 w over 4 w, 6 plus w, times 9 w squared, w plus 6, over 6 w, w minus 1. Now that I stated NPVs, I can also make this a whole one. Okay, what can I cancel? W plus 6 and 6 plus w are the same thing. A w for a w here. A w here for one of these w's, so I'm still left with w to the 1. Then I think I might be done. So I'm going to put together my numbers. 2 times 9 is 18, and I still have a w. In the bottom, I have 6 times 4, which is 24. And I have a w minus 1. Now those w's are not going to cancel because w minus 1 is attached. It's only going away if there's a w minus 1 in the numerator, which there's not. But 18 and 24, I can take a 6 out of both. 18 divided by 6 is 3. 24 divided by 6 is 4. So I'm actually going to end up with 3w over 4 w minus 1. With my NPVs, w cannot equal 0, negative 6, and 1. Then we go to D. D is a minus 6. Can't do anything to that. The denominator, 3a squared plus 9a, I can take out a 3a. 3a squared divided by 3a is a, plus 9a divided by 3a is 3, negative 3, and an a, divided by a plus 3, and if there isn't a denominator, it's 1. So I can flip and multiply. I get a minus 6 over 3, a plus 3, times 1 over a plus 3. Then I state my NPVs. 3a, a plus 3, a plus 3. Well, there's 2 of those, so I don't have to do it twice. So I'm going to go 3 cannot equal 0, not an NPV. A cannot equal 0 is 1. And then a plus 3 cannot equal 0, subtract 3. A cannot equal negative 3. And then I have an a, I can put these together. And then I have an a minus 6 in the top, and that's it. And I don't have an a minus 6 in the bottom, so I can't simplify it anymore. So I'm going to be left with a minus 6 in the top, and then 3a. And then I could go a plus 3 times a plus 3 and write it out like that. Or, because there's two of them, I can actually go a plus 3 squared raised to the exponent 2. And then I have a cannot equal 0 or negative 3. At any point in time you want to try these on your own, please go ahead. Try them out first and then check and see if you got them right. So here's a your turn. You could pause it and then try it out and then play it, see if you got it right. So it says simplify the following rational expression and state NPVs. So the top left, I have x cubed plus x squared. I can take out an x squared. X cubed divided by x squared is x, plus x squared divided by x squared is a 1. It doesn't just go away. Remember, when you take a GCF out of two terms, you need to still have two terms in that bracket. So please don't forget that 1, okay? That's where people get in trouble. And then we have a 16 in the bottom. And then divided by x squared plus x, I can take an x out. When I take an x out of x squared, I'm left with x, plus x divided by x is 1. So once again, I hope you have that 1. If you did this question before me and then paused it like I asked, and then came back and you didn't have the 1, write yourself a note to remind yourself that you need to have a 1 when you divide two terms that are the same. Then I have 20x minus 10. I can take out a 10. 20x divided by 10 is 2x. And then 10 divided by minus 10 divided by 10, negative 10 divided by 10 is negative 1. Wow, that was hard for me to say. All right. Then we can rewrite it with a multiplication and flip the right-hand side. So we have x squared and then x plus 1 over 16 times 10, 2x minus 1 over x plus 1. And then you actually get it completely across. But before we put it completely across, we have to state those NPVs, right? Of everything but the x squared and x plus 1. I just caught myself covering it with my hand, like as if you can see it. Oh my goodness, I should stop. Okay, so you're going to state it for everything but the top left. So I'm going to start on the right, bottom left. Oh my gosh. So I'm going to say 16 cannot equal 0, which is true. Oh my gosh, come on, iPad. True, but not an NPV. And then I have x cannot equal 0. That one's done. And then I have x plus 1 cannot equal 0. Subtract 1. X cannot equal negative 1. And then I have 10 cannot equal 0 because of these ones, which isn't an NPV. And then I have 2x minus 1 cannot equal 0. Add 1. And I get 2x cannot equal 1. Divide by 2. X cannot equal a half. Those are my NPVs. Now I have my NPVs. I can cancel anything that's common on the top and the bottom. So I have an x plus 1 and an x plus 1 that can go. This x can take off one of these x's, so I still left with x to the 1. And I think that's as good as it gets. So I'm going to get 10 x. 2x minus 1 isn't going anywhere because there's no 2x minus 1 on the bottom. Over 16. And then I say, I can take a 2 out of the 10 and the 16. If I take a 2 out of 10, I'm left with a 5. A 2 out of 16, I'm left with an 8. So my answer is actually 5x, 2x minus 1 over 8, with x cannot equal 0, negative 1, oh my gosh, and a half. That isn't messy. My goodness. Sorry, so messy. I have to erase this one spot. Write it again. Negative 1. There we go. All right. Last page. 2 more left. So these 2 you could try on your own again, like I said, okay? And this is when it gets a bit harder. So I have 30x squared plus 15. 15x, sorry. So I can take a 15x out. When I take 30x squared and I take a 15x out, I'm left with 2x plus 15x divided by 15x is a 1. So it doesn't go away. You're still left with that 1, remember? The bottom is a difference of squares. So x squared minus 9 is a difference of squares. If I take the square root of x squared, I get x. If I take the square root of 9, I get 3. So I'm going to get x plus 3x minus 3 divided by the top right. I can take out an x squared. 2x cubed divided by x squared is 2x. And then x squared divided by x squared is a plus 1. And then on the bottom I have x squared minus 3x. I can take out an x. Take an x out of x squared, I'm left with x. X out of 3x, I'm left with negative 3. Then I can flip it. So I'm going to get 15x, 2x plus 1. The only part I don't state NPVs is for this top left when it's division. And then I get x plus 3, x minus 3 times x minus 3 over x squared, 2x plus 1. And I can do my NPVs over here. And they're going to be for this, 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 this. So I have, do them in gray, x plus 3 cannot equal 0. X minus 3 cannot equal 0. X squared cannot equal 0. 2x plus 1 cannot equal 0. X cannot equal 0. And then x minus 3 cannot equal 0. But I already stated that one up here, so I don't need to do it down here. Okay. So I'm going to minus 3 from both sides. I'm going to get x cannot equal negative 3. So I'm going to add 3 to both sides. I'm going to get x cannot equal positive 3. Take the square root, plus or minus. The square root of 0 is 0, so x cannot equal 0. So a bad spot on my iPad. And it's already stated down here, so I don't need to state it twice. Then here I'm going to minus 1 from both sides. And I'm going to get 2x cannot equal negative 1. And I'm going to erase that out. And then I'm going to divide by 2 to get the x 2 away from the x, and I get x cannot equal negative a half. So I have 4 non-permissible values. Once I have that stated, I can make this one whole fraction. So the x minus 3's cancel, the 2x plus 1's cancel, the x squared cancels off one of these x's. Oh, and there's another x, so it cancels completely off the x squared. And then I think I have everything. So I'm going to have 15 on the top, and that's it. Everything else canceled off. And on the bottom, I have x plus 3. Nothing more I can do to that. So I just state my NPVs. X cannot equal plus or minus 3, 0, and negative a half. Once again, you can pause this one and try it out on your own. The top left, 4x squared minus 1 is a difference of squares. 4x squared, square root of that is 2x, and the square root of 1 is 1. So on the top left, I'm going to get 2x plus 1, 2x minus 1. The bottom left, I have x plus 2, and there's nothing I can do to it. The top right, I have 4x squared plus 2x. I can take a 2 and an x out. 4x squared, take out 2x, and I'm left with 2x. And then 2x, take out a 2x, I'm left with a plus 1. And the 2 and the x can go in their own brackets. The bottom, I can take an 8 out. I'm just going to show you here. When I take an 8 out, I'm left with x squared minus 4. And x squared minus 4 is the difference of squares. So I'm actually going to get 8, x plus 2, x minus 2. So you have to watch and see. Sometimes you take a GCF out and you have a difference of squares waiting for you. So we're going to have 8, x plus 2, x minus 2. Then we can flip it. So we get 2x plus 1, 2x minus 1, x plus 2, times 8, x plus 2, x minus 2, over 2x, 2x plus 1. So before I go to put these together, I have to state my non-permissible values. It's going to be this one, this one, this one, this one, this one, this one, this one. There's lots. So I get x plus 2 cannot equal 0. 2 cannot equal 0. But that's not an NPV. X cannot equal 0. That one's done. 2x plus 1 cannot equal 0. 8 cannot equal 0, which is true but not a non-permissible value. X plus 2 I've already stated up here. And then I just have left x minus 2 cannot equal 0. Then I have to go back and solve them. So here I'm going to subtract 2. So I'm going to get x cannot equal negative 2. And I'm going to subtract 1 from 2x minus 1. So I get 2x cannot equal negative 1. And then I'm going to divide by 2 to get x by itself. So x cannot equal negative a half. Then here I'm going to add 2. So x cannot equal 2. So I have 4 NPVs. Negative 2, positive 2, 0, and negative a half. Now I can put these together. Get out my black marker. 2x plus 1, 2x plus 1 cancels, x plus 2, x plus 2, and I think I'm done. So I get 8. I always state my coefficient, my number that's by itself first, no matter where it is. 2x minus 1, x minus 2, over 2, and x. Now this bottom x is not canceling anything off because the top has 2x minus 1 and there's no 2x minus 1 in the bottom, and it has x minus 2 and there's no x minus 2. So this x is staying. But the 8 and the 2, I could take a 2 out of, sorry. 8 divided by 2 is 4, 2 divided by 2 is 1. So I'm left with 4, 2x minus 1, x minus 2, over 1x, or I could just say x. And then I say x cannot equal 0, negative a half, plus or minus 2. And that's it, that's all. So that's multiplying and dividing rationals. So they're quite similar. And like I said, if you're stuck, please still message me, ask me to sit down with you and I can help you. Sometimes one-on-one just makes it so much easier, okay? Yeah, so all we have left next week is adding and subtracting of rationals, and then a review assignment, and then you're done, grade 12, which is crazy. Oh my goodness. That is crazy. So I hope you guys have a wonderful weekend, and I hope that you find this easy, but if you do not, please, please, please message me. Talk to you later, guys.